Hello. Whenever I play OpenTTD, I get to a point where my trains keep getting lost or stuck, or even crash. So I gave myself a challenge to help me learn how the signalling mechanics work. That challenge was to make an 8-bit calculator out of trains and signals. There are a few types of signal that I'm going to be using. The first is the basic block signal, which is red if there are any trains in the section ahead, and green otherwise. Exit signals are red if there are any trains in the section ahead, and sends a signal backwards towards any entry signals. And entry signals, which are red if there are any train in the section ahead, or if all exit signals ahead are also red. Then there's also the combined signal, which behaves like both an entry and an exit signal. Now, there's also a fifth kind of signal, the path signal, and to be honest, these just work by magic, so I'm not going to be using these. The calculator I'm building will add two 8-bit numbers together. I will do this by using a full adder, a diagram of which from Wikipedia should be on screen now. One of these is built from 9 NAND logic gates, so I need to work out how to build those first. The most basic logic gate is a NOT gate, which returns true if the input is false, and vice versa. In this context, if a train enters the gate, then no train leaves, and if no train enters, then a train does leave. This is my design for a NOT gate. This is a train which I call the clock. When it goes past the gate, it'll set the logic in motion. This train is the input train. The value of the input is determined by whether or not this train is present in this area. And this train is the output train. It's currently getting a red signal from the clock. Once the clock passes, it'll get a green signal and come across these signals. They are currently green because there is no input train in this area. However, if there were an input train there, they would be red and the output train would not be able to leave. The next one is a NAND gate, which outputs false if and only if both of the inputs are true. So here I have set up two exit signals behind the inputs and a single entry signal in front of the output. If either of the input trains are not present in these two areas, then the output train will get a green light. And finally, this is what I call a doubler, which causes two trains to leave if a single train enters. This is needed because some of the gate's outputs are used as input by more than one subsequent gate. This is formed of one NOT gate, followed by two more NOT gates in parallel, sharing the same input. And so here's the final design for my adding calculator. In addition to the NAND gates and doublers, there is some extra logic to help with timing and to allow the entire setup to reset itself. It needs to reset itself since it runs 8 times in a row. First it adds the least significant bit, before moving on to the second least, and so on. Here is a spreadsheet I made that generates random numbers and can convert to and from binary. So these two binary numbers are what I'll input into my calculator. Ultimately, we expect the answer to be 181. So the first input is 45, which is 00101101. The second input is 136, which is 10001000. I'll follow the first run through of the adder at normal speed. For the following 7, I'll speed up the game. Skip ahead to 11 minutes if you just want to see the answer. And this is our final answer. If we read which trains are in the stations, we can see that the answer is 10110101. Typing that back into the spreadsheet, we can see that the answer does in fact correspond to 181, which is what we expected.